Alright, problem 7D, last graphing one. Absolutely no space to do this on your worksheet. But again, it's a rational function, so we need to factor the numerator and factor the denominator. In the numerator, notice that we are dealing with four terms there, and notice that the first and third are the same, and the second and fourth are the same, minus, a negative sign there. This is a pretty big tip-off that we're going to be using factoring by grouping. So let's go ahead and focus on this numerator there. Of those first two terms, what can I factor out? Well, I can certainly pull out a negative 2, and I can also pull out x squared. So let's pull out negative 2 x squared, and what are we left with? We're left with x plus 3, because 3 times negative 2x squared is negative 6x squared, and x times negative 2x squared is negative 2x cubed. Then let's look at those next two terms, and we'll get a plus 2x plus 6. What can I pull out? Well, I'm going to pull out a 2, because then I'm left with x plus 3. Again, 2 times x is 2x, 2 times 3 is 6. Notice, same factor in both of these terms, so we factor that out now to get x plus 3 times negative 2x squared plus 2. So I'm actually going to factor that further by pulling out the negative 2. So we'll get negative 2 out front times x plus 3 times x squared, and that will give me a minus 1 right there. Oh, look at that, difference of squares. So this will factor further as x plus 1, x minus 1. So now that is my numerator completely factored. Look at the denominator here, x squared plus 4x plus 3. Well, that's going to factor as x, whoa, that was weird. That's going to factor as x plus 3 times x plus 1. And then x squared plus 10x plus 25, that's a perfect square, so we'll get x plus 5 quantity squared. So now let's look at this all together. We're going to take this, and we're going to throw it underneath this right there, so we can look at this all together and identify the different components that we have. So notice that we have an x plus 1 and an x plus 1 and an x plus 3 and an x plus 3. So we're going to have a whole at x equals negative 3 and negative 1. Notice that x plus 5 squared in the denominator. That will give us a vertical asymptote when x is negative 5. Notice that x minus 1 in the numerator. That will give us a 0 when x equals 1. And that negative 2 isn't doing all that much. It's going to affect what our graph looks like, but it's not giving us any of these features here. Horizontal asymptote then, notice that this function simplifies down when you remove those holes to negative 2 times x minus 1 divided by x plus 5 squared. So the degree of the denominator is 2, while the degree of the numerator is only 1, meaning that this function has a horizontal asymptote at y equals 0. So domain is going to be domain is going to be x in R such that x is not equal to negative 5, negative 3, or negative 1. Range, I'll figure that out in a moment because now I need to figure out the y value of my holes. So let's plug negative 3 into this simplified function. So negative 2 times negative 3 minus 1 over negative 3 plus 5 quantity squared. Negative 3 minus 1 is negative 4 times negative 2 is positive 8 divided by negative 3 plus 5 is 5 minus 3 is 2 squared is 4. So I get 8 over 4 is 2. So that tells me that the y value of the whole at x equals negative 3 is 2. So for my range, I can get started. Now that y is going to be an element of R such that y is not equal to 2. And let's see what else. Let's plug in that value of, what was it? -1. Okay, so -2 times -1 minus 1 divided by, parentheses, -1 plus 5, quantity squared. So I get -2 times -1 minus 1 is also -2. So -2 times -2 is positive 4. Divided by 5 minus 1 is 4. Squared is 16. 4 over 16 is 1/4. So that other y value is 1/4. And then don't forget about that horizontal asymptote at 0. But actually, I know that I have a 0, so that has to be in my range. So that's going to be my range right there. Let's piece this all together. Horizontal asymptote at 0. Vertical asymptote at -5. 1, 2, 3, 4, 5. Dash that in. What else do we know is 0 at +1. So 0 right there. And what do we know? We have a hole at -3. So I'm going to put that like that just as a reminder, and a hole at -1. Another reminder there. But actually, I found the y value. So -3, I know I am at, it was -2? No, it was +2. So I know that hole is right there. So I can start making this a little more accurate. At -1, it was 1/4. So that hole is going to be like right there. So let's see how this works then. Let's take note of that 0. The factor that's giving us that 0, x minus 1, has a multiplicity of 1, which tells me that this 0 is going to cross there. So let's figure out where I am to the right of that 0. Actually no, let's make it easier. Let's figure out where I am to the left of that 0, because then I can just plug in 0. So plug in x equals 0. We get -2 times -1 over 5 squared. So -2 times -1 gives us a positive number. 5 squared is positive. So we know that to the left of this 0, right in this area right here, I am positive, which tells me that over here I have to be negative since I cross at that 0. So I know that we have to have some sort of situation like this, where I've crossed, but then I am approaching that asymptote like that, and which means that here I gotta go up to that thing, hit that hole, curve up to that feller right there, and then approach that asymptote right there. And since that asymptote has a multiplicity of 2 right there, I know that means that my tails will be together, so I know that this function will come down and look like that. And I believe that should be it. We shouldn't really get this like frumpy bit right there. It should be nice and like perfectly smooth, but you know, I'm not perfect. And I just realized that we have a slight problem with our range, because our range is implying that it's all y values other than 2 and 1/4. But that's not true, because look at all this stuff down here that we don't hit. So if we really wanted to figure out our range precisely, what could we do? Well, think about this. If we're coming down, I'm going to overemphasize this. If we're coming down like that and crossing and then going up like that, we should have at some point here a minimum value. So we could take the derivative of this function and figure out when it is equal to 0, and then whatever x value that is would tell us our lowest point if we plugged that x value back into our function. So we could do that and figure out the lowest y value of this graph. But I'm totally not doing that right now.